Welcome back. We're in Khan Academy on Algebra 1, and we're in the unit Quadratic Functions and Equations. This set of problems is called Quadratic Word Problems, vertex form. So we learned about vertex form in the previous video. We'll continue learning about it now. The vertex form of a quadratic equation looks like this in general, where y and x are variables. A, h, and k are all constants. So y equals a times the difference between x and h squared plus k. If it's in this form, we know that the vertex of that parabola occurs where x equals h and y equals k. The vertex is located at h comma k. Okay, so in this problem, let's see what we have. We've got an equation of a parabola in vertex form, -3 times x minus 3 squared plus 108. So we know right now that the vertex is at 3 comma 108. The x-coordinate is the opposite sign of this sign that's inside of the parentheses, and then that value of that constant. So it's the opposite of -3, which is +3. And then its y-coordinate is the constant here with the same sign. So this is +108, so the y-coordinate is +108. Question is, what's the height of the hovercraft at the time of takeoff? Well, let's get some context. The hovercraft takes off from a platform. So here's a platform. Hovercraft takes off, and then it lands sometime later. Its height is measured in meters, x seconds after takeoff. So the x direction is our time, and the y direction is our meters off the ground. So this is going to be modeled like here. Here's a platform. It takes off, and it lands on the ground over here. Okay, so my y-axis is there, x-axis is here. What's the height of the hovercraft at the time of takeoff? At the time of takeoff. Well, this is in vertex form, so we know that that is the coordinate right here. At the time of takeoff, if x is our seconds after takeoff, at the moment we've taken off, we also start the timer, right? So the time is 0. That means x is 0 at the moment of takeoff, and we want to know what the height is. Well, that's what the function tells us. So we'll put 0 in for x. We'll substitute 0 for x, and we get h of 0 equals -3 times 0 minus 3 is -3 squared plus 108. Squaring -3 is 9. 9 times -3 is -27. So -27 plus 108 is, oh what? It's 1. It's 81. Okay, so at time 0, we're 81 feet off the ground. Meters, 81 meters. Alright, here's another context. The fish population in a certain part of the ocean, in thousands of fish, as a function of the water's temperature in degrees Celsius, is modeled by p of x equals -2 times x minus 9 squared plus 200. What temperature will result in the maximum number of fish? Okay, the question is about the maximum of the function. This is a parabola. We know that because x is being squared at some point here, and that's the highest degree term. We also know that the parabola opens down because this constant is negative. So the graph is going to look like this, which means it has a maximum value. At some point, we get as high as we can be. That point is the vertex of the equation, and this equation is written in vertex form, which means The coordinates of the vertex are sitting right there. It's the opposite of -9, which is 9. That's our x coordinate. And then the y coordinate is this constant, positive 200. So let's look at, what does this mean? What temperature will result in the maximum number of fish? Remember, it's a function of temperature, so x is the temperature. They're asking us what temperature, so what x value gives us the maximum number of fish. Number of fish is what the function gives us. So they're asking us for the x value that maximizes the number of fish. The number of fish is 200, and that happens at 9 degrees Celsius. 9 degrees Celsius. Next problem, an object is launched from a platform. Its height in meters x seconds after the launch is modeled by this. The question is, how many seconds after being launched will the object hit the ground? Okay, this parabola also opens down because we have a negative leading coefficient. So at some point, it hits the ground, right over here. It started off on a platform, right here. So my graph will look something like that. We know from vertex form that this has a vertex at 4, 180. The opposite of -4 for our x coordinate and positive 180 for our y coordinate. And they want to know how many seconds after being launched will the object hit the ground. Well, that's this point right here. How many seconds is x, so they want to know the x coordinate when y equals 0, right? Y equals 0 here. It would also have equaled 0 there, but that time didn't exist because it was a negative time, so you wouldn't even have this part of the graph. It's not actually existing. But we need to figure out, when does the function equal 0? Okay, let's figure that out. So we have 0 equals all of this stuff, -5 x minus 4 squared plus 180. So we'll subtract 180 from both sides, get -180 equals -5 times x minus 4 squared. Divide both sides by -5, and that gives us, let's see, 36 equals x minus 4 squared. If we take the square root, we get plus or minus 6 equals x minus 4. Now, the -6 is going to correspond to this point over here that doesn't actually exist. And the positive 6 will be headed to the right. So 6 equals x minus 4. We'll solve for x by adding 4. That will end up being 10. So 10 seconds after this takes off, it lands on the ground. Ying is a professional deep water free diver. His altitude in meters relative to sea level is d of x, is x seconds after diving. Okay, x seconds after diving. So seconds is our x, altitude in meters relative to sea level is d. What's the lowest altitude he'll reach? Notice we have a positive leading coefficient, which means that our parabola opens up, and you'll notice that this being positive, this part of the expression is positive, and we subtract 100 from it. Well, what does that mean? If this is always positive, then we can only increase from -100. So we know right now that the lowest point there is -100. And that happens because this is vertex form, that'd be the vertex, at 60 seconds. That's all they asked us about this. So, we know our answer. What's the lowest altitude? Well, altitude is D, or the y value, so that's negative 100. And we're done.